All right, let's talk about improper integrals. Now, what is an improper integral? There's really two types of improper integrals, and the issue is they're a lot like definite integrals, except that um, they have some sort of indefinite boundary. Um, and so one case of that is where we have an infinite interval, where we're integrating to infinity, or we're integrating from minus infinity to some value, or we could even integrate from minus infinity to positive infinity. The other type of indefinite integral involves integrating it either at or across some discontinuity in the function. So we're going to look at those types of integrals today. Now, we're going to start it by looking at this integral from 1 to infinity of 1 over x squared dx. So we're trying to basically integrate all the way out to infinity, which you would think, is that really possible? Is it going to tell you anything other than infinity? If you're integrating to infinity, why wouldn't it just be infinity? But let's take a look at this function, 1 over x squared, okay? So I'm going to try to draw what this function looks like. So now as x approaches 0, 1 over x squared becomes large. And then as x approaches infinity, it looks like 0. So that's what the right-hand side of the curve looks like. If we wanted to look at the left-hand side of the curve, because it's squared, anything squared is going to be positive. So it's essentially a mirror image on the other side. So it's going to go from 0 and then go up to infinity. So it looks something like that. Okay, if I draw this is the y-axis and this is the x-axis. Okay, so that's sort of what the function looks like. I didn't make it perfectly mirrored, but you get the idea. And of course, 1 over 1 squared is 1, so we have this value 1 comma 1. And we're trying to integrate the area, we're trying to find essentially the area under the curve between 1 and infinity. And now this area keeps getting smaller and smaller and smaller and smaller as, x gets larger. So but I guess the question is, are you really going to get a finite value? So, now I'm not sure at this point how to integrate all the way out to infinity. But what I can do is integrate out to some value, some arbitrary value t. Because I can find the integral from, the definite integral from 1 to any point t. So that's the way I'm going to start. That's the way I'm going to start this problem. I'm going to look at the integral from 1 to some arbitrary value t of 1 over x squared dx. All right, so that's just the integral of x to the minus 2. It's a little easier to deal with when it looks like that. And so what I'm going to get is basically 1 over minus 1, x to the minus 1. And I'm going to evaluate it from 1 to t, just like I would any other definite integral. So when I evaluate that, I get essentially this 1, x to the minus 1 is 1 over x. So when I evaluate it at t, I get minus 1 over t. And then when I evaluate this at 1, I get it's going to be minus a minus 1. So it's going to be end up being plus 1. Okay, because it's 1 over 1. So, all right, so now we've evaluated a definite integral, but to some arbitrary point t. And then the trick is to see what happens as t goes to infinity. So I'm going to take the limit as t goes to infinity of the result of this definite integral evaluated out to t. So I'm going to evaluate that. And of course this negative 1 over t goes to 0. And then 1, when I evaluate that out to infinity is just 1. Okay, so my answer is actually just 1. The value, the area under this curve, 1 over x squared, from 1 to infinity is a finite value, and it's just 1. So that's essentially how improper integrals work. So this type 1 is the type where you have an infinite interval, right? So you're your upper bound, or it could be your lower bound, is infinite. And so if you look at this definition down here, we have basically three different types. Either we're integrating from some value up to infinity, like we just did, and in that case, you evaluate it out to t, and then do the limit as t approaches infinity. Or you can have an improper integral where the lower bound is minus infinity up to some value, but you do the same thing, only this time you're going to look at the limit as t goes to minus infinity, and your lower bound is t. And you can also do a combination of the two things. You can look at the integral from minus infinity to infinity of some function, and all you need to do is just split it up into two parts. All right, it's basically the same thing. You're going to integrate from minus infinity to some a, and you can choose basically whatever you want for a, as long as it's, as long as this function is continuous, right? So you can choose whatever you want for a, and then add to that the integral from a to infinity, and then you'll have the integral from minus infinity to infinity. Okay, so we're going to go on and do a few more examples of this type 1 improper integral, and then I'll tell you about the other type where we have a discontinuity.